Hey class, Mrs. Lowe here. I'm working in Lesson 3, Unit 5, Solving Systems of Equations, Linear Equations. And you're going to learn 3 methods on how to solve graphing, which could be a combination of algebra and then having to accurately graph, which has its downfalls. The second method is substitution, and the third is elimination. So we're going to first do graphing. Now, to solve a system of equation means to find the point of intersection, the actual coordinate point where 2 lines cross. And a solution to a system of linear equations satisfies both equations. So you can see here I have 2 lines, they cross at a particular point x, y. If you plug them in that intersection point into both equations, it works for both. If it only worked for one, it's not a solution. And it can't possibly have 2 points of intersection because then you're just looking at the same line crossing over itself. So graphing is best used when both equations are in the form y equals mx plus b, or it's easy to convert to this form, and also when b are integers, because it's difficult to graph if you don't have integers for your y-intercept. So if it's not a y-intercepts are not integers, you're probably going to need to use a table of values. So I'm going to do a problem on the next page, number 4 at the bottom right. So graphing wouldn't be too bad for this problem, though I would probably use elimination because it would only take 30 seconds, but I'm going to use graphing for this one. I can either do like intercepts and graph, I could do a table of values and graph, or I could solve each one for y equals mx plus b and then graph. So I'm going to solve each one for y equals mx plus b and graph. Now I like to use colors because I'm a visual person, and some teachers will number their lines, but I like to use colors. So I'm going to first solve this for y, and remember when I mean by solve for y, I just mean get y by itself. And I simply do that by moving the 4x over, and it becomes negative. So now I'm ready to graph. The y-intercept is 2, the slope is negative 4, so I can go up 4 over 1 to the left, or I could go down 4 over 1 to the left. So 1, 2, 3, 4, or excuse me, 1 to the right. And let's make sure I have an error here. If you guys didn't notice that, I didn't go up far enough. So this one is actually off the chart. 1, 2, 3, 4 over 1. So that's at 6, negative 1. Then you need to use a straight edge to draw your lines because you want to be perfectly accurate. You guys hear my dogs drinking in the background? I have to ruin the video. So, and you guys know that you should have lines, or excuse me, arrows on the end of those. So that is the equation of the line, y equals negative 4x plus 2. I'm going to use a different color for the second graph of the line. And again, I'm going to solve this for y. Well, y has to be positive, so instead of moving the x over and then switching all the signs, I'm going to move y to the right and 3 to the left. So I'm going to move y over here. It's going to become positive. And I'm going to move 3 over here, and it's going to become negative. So I have x minus 3. And we're used to seeing it in y equals mx plus b, so I'm going to use the property of symmetry, and I'm simply going to flip over the equation. And the number in front of the x is 1, and I can make that look like a fraction by putting it 1 over 1. So I know the rise is 1, and the run is 1. The y-intercept is negative 3, and I'm going to go up 1 over 1. Up, notice, there it is. There's the point of intersection. I want to keep going and draw my line accurately. It's very important when you solve by graphing. It has to be accurate, and you have to use a straight edge. You need to use integer points. And again, that is a part of the downfalls of the graphing method. So I have drawn my lines. Again, I need to put arrows on the end because lines go on forever. These are not segments. And the most forgotten part of this is actually stating the point of intersection. The solution to this system of equations is 1, negative 2. So make sure you write the solution as an ordered pair with parentheses around it because it is a point, a location on the graph. To show that it satisfies both, we could do a quick check. So if I put it in the green equation, the left-hand side should equal the right-hand side. And sure enough, 4 plus negative 2 is 2. See how it satisfies that equation? I'm going to put it in the blue equation now. 1 minus negative 2 equals 3. 1 minus negative 2 is 3 equals 3. Check. So this point is the solution to the system equation. I've showed that it satisfies both as well. Okay, hope that helps.